All right, in this video, we are going to be going over our 5.3 notes, which is going to be interpreting solutions to absolute value inequalities. This is going to be your AMI day assignment to take these notes and then just fill out the Google form on Schoology. So really quick before we begin, we're just going to review what we talked about yesterday, which is this box right here. When we have absolute value inequalities, if it's less than, we make it an and statement. If it's greater than, or it could be greater than or equal to, either one of those. If it has greater than, it's going to be great, or it's going to be an or statement. So let's jump right in with example 1. So remember, the first step is we always need to get the bars by themselves. So here we would divide by 2 on both sides. So we would have x plus 1 absolute value is greater than or equal to negative 16. Now, from here, since this is great or, we could separate this into an or statement, but I want you to notice something about this right-hand side. If we have an absolute value of something, that number is always going to be either positive or 0 when it comes out of the absolute value. Because when you take the absolute value of something, it's never going to be negative. So if we think about the fact that we have a positive or 0, greater than or equal to a negative, that's always going to be true. A positive number is always going to be greater than a bigger number. So if you have a negative number over here, you actually have less work to do, because everything, this is always going to work. So what we would have is our entire number line, and we would say negative infinity to positive infinity. And that would be our answer for that. So down here, again, we're going to get the absolute value bars alone first. So yesterday we talked about if we want to get rid of a fraction, we can multiply by the denominator. So I'm going to multiply this whole thing by 5. So I multiply that term. This is one term. So really I just have to multiply the fraction. And then I multiply that by 5. So I have the absolute value of 2x minus 1, because 5 over 1/5, that would just be 1, and multiplying by 1 is not going to do anything, is less than negative 25. So again, we have a negative number over here, so that if you see a negative number, I want you to stop and think about what's happening. So when we take the absolute value of something, the result is either going to be positive or it's going to be 0. So we're saying a positive number is less than negative 25. A positive number or 0 is never, ever going to be less than a negative number. So this is never going to work. This statement will never work. So we would leave our graph blank and we would say no solution. Because there's no number that you can put in here. Like when you take the absolute value, you're always going to get a positive number or you're going to get 0. And that's never going to be less than negative 25. Okay, down here, the absolute value bars are already by themselves. We don't have a negative number over here, so we are going to have to actually show our work, split this up. So it is less than, so this is going to be an and statement. And we can jump right into splitting this up because the absolute value bars are already by themselves. So we're going to have 7x plus 3 is less than or equal to 0. And 7x plus 3, we're going to flip the sign. So we have greater than or equal to 0. And then, I guess, negative 0, but negative 0 is just 0. So now we're going to solve. So I'm going to subtract 3 from both sides. Divide by 7. So I get x is less than or equal to negative 3 over 7. I'm going to do the same thing over here real quick. So this is my statement that I have. I have x is less than or equal to negative 3 over 7, and x is greater than or equal to negative 3 over 7. So we have to figure out where is this true at the same time. So remember, when you have an and statement, I want you to have your final answer and a rough draft. So if I were to graph this, the only number we have is negative 3 over 7. This one looks like this. Closed circle going to the left. This one looks like this. Closed circle going to the right. So the only place they overlap is at negative 3 over 7. So the only solution is negative 3 over 7. That's it. That's the only thing that works. So this is a bit of a strange inequality, because normally with inequality we either have lots of answers or no answers like we saw here. But with this one, we just have one. The only place where our overlap is that one point. Okay, we only have 2 more left. So on the next page, we have example 6. We are going to have to get the absolute value bars alone first. And this is going to be great or, so this is going to be an or statement. I'm going to go ahead and write that down. And then we're going to subtract 5. So the absolute value of x minus 9 is greater than 0. Okay, 0 is not a negative number, so we're going to have to split this up. We can't jump to conclusions. So we're going to have x, well, that's an ugly x. X minus 9 is greater than 0, or x minus 9, flip the sign, or flip the symbol and flip the sign. So now we're going to solve for x. Luckily, this one isn't too bad. We're just going to add 9 to both sides. All right, so this is what we have. X is greater than 9 or x is less than 9. Since it's an or statement, we can go ahead and graph both of them on the number line. So if I put 9 on the number line, let me graph this. X is greater than 9 is going to be an open circle going to the right. If I have x is less than 9, I'm going to have an open circle going to the left. So if I want to write this in interval notation, it's going to look a little weird because we go from negative infinity all the way till 9, but then we actually stop, but we only stop at 9. So we're going to put a parenthesis at 9, put a union symbol, and we actually pick back up at 9. So this is a very fancy way of saying everything but 9 works. Because if we were to put 9 into our inequality, 9 minus 9 would give us 0. The absolute value of 0 is 0. 0 plus 5 would give us 5. 5 greater than 5, not a true statement. 9 doesn't work. It's the only thing that doesn't work. Last one. So this one is less than. So this is going to be an and statement. And we're actually already ready to break it up. So we have 2x minus 1 is less than 9x minus 1. So our first inequality is exactly what's given to us, just without the absolute value bars. Then we're going to write and. We're going to keep the left side the same. So whatever's in the absolute value bars, that stays the same. But then our symbol flips. And both of these signs change. So now we have negative 9x plus 1. And now we get to solve. So I'm going to, since it's an inequality, I'm going to keep my x on the left-hand side. So I'm going to subtract 9x from both sides. You always want to get rid of an x. Add 1 to both sides gives us negative 7x is less than 0. When we divide by negative 7, be very careful. We're dividing by a negative, so we flip our sign, and then 0 divided by anything is 0. Then we're going to go over here and solve. Add 9x to both sides. Again, since it's an inequality, I like to keep my x on the left-hand side. That way, when I'm reading the inequality, it just makes more sense to me. add 1 to both sides. Divide by 11, and we're going to get a really crazy decimal here, so we're going to leave this as a fraction. Okay, we have an and statement. So you know what that means. We have our final answer, and we're going to have to make a rough draft. Put your smaller number first on your number line, so we would have 0, and then 2 over 11. We're going to graph both of these inequalities and see where they overlap. So open circle going to the right, open circle going to the right. And so this is a little different than everything we saw yesterday, because everything we saw yesterday, the overlap was in the middle, but this is to show you that the overlap can be on the side. So this is where our overlap is. This is where our inequalities are true at the same time. So this is where our answers are. Because it's an and, we had to look for the overlap. So on my number line, I'm just going to have 2 over 11. I'm going to have an open circle going to the right. And then my interval notation, if I'm reading this from left to right, I start at 2 over 11 and I go all the way to infinity. Pretend that's a parenthesis. So that is your special cases notes. Again, for your AMI day, please make sure you fill out the Google form on Schoology so that I can count your attendance.